Okay, so we're looking at number 8 on page 3 now. The ratios of the side length triangle PQR to the corresponding side lengths of triangle STU are 1 to 3. Find the unknown lengths. You may need to use Pythagorean theorem. Okay, so first thing I want to make sure we know is that when you see this ratio of 1 to 3, the 1 correlates with the PQR. So as you notice, the PQR is smaller than triangle STU. So the STU corresponds with the 3 in that ratio. So first one, let's go ahead and try to find Y first. So in this one, this is our smaller triangle. So this is going to be what's in the numerator. So I have Y over what it correlates with. RQ correlates with UT. So if you don't remember how to recognize it, this was our CPCTC. The corresponding parts of congruent triangles are congruent. So you can just look at the letters here and see what they go with. So P goes with S, Q goes with T, and R goes with U. So RQ went with UT. So Y over 36 is supposed to be equal to the ratio 1 to 3. Now that I have this ratio, what I want to do is cross multiply. So Y times 3 and 36 times 1. So you're going to have 3Y equals 36. Next step, divide by 3. That'll cancel it out on that side. So Y equals 12. So our Y value is 12. So that's one of the side lengths that we had to find. The next one we can find, why don't we go ahead and find X now? So X is from our big triangle, so that's going to be in our denominator. So X will be in our denominator. So we have to find out what SU goes with though. So SU goes with PR. So PR is 5. And it's supposed to go to a ratio of 1 to 3. So in other words, this triangle is 3 times bigger than this triangle. So if I did my cross multiplication, then I would have 15 equals X. So X would be equal to 15. Now, another way that I could have found each of these, if this one is 3 times bigger than this one, well, if I had 5 for this side, multiply it by 3, I got 15. Then if I were trying to find Y, well, this one is the bigger one, so divide 36 by 3, I would have got 12. Now, I can't do that right now for the Z or the W because I don't have a value yet. I need to actually find a value first. So this is where they're saying you may need to use Pythagorean theorem. What we're going to do is I'm going to choose this triangle to do Pythagorean theorem to. I could have done the other one. It does not matter. So if you don't remember what Pythagorean theorem is, that is a squared plus b squared equals c squared, where c is the hypotenuse, so the longest side in the right triangle, and a and the b are the legs. So what I would have is 5 squared plus 12 squared equals what we're trying to find, which is the hypotenuse, so equals c squared. 5 squared is 25. 12 squared is 144. And this is all equal to c squared. So now I can add those together. I would get 169 equals c squared. Well, the way to get rid of a square is to square root it. So the square root of 169 is 13. So z in this case was equal to 13. Now, we're not done because we haven't found the last length here. Well, if I want to find that length, I could do my proportion. So I would have 13 over W equals the ratio of 1 to 3. Do our cross product, or cross multiplication. And W times 1 is still W. And then 3 times 13 is 39. So the length of W would be 39. So we're again on page 3. We are now looking at number 10. This one says the exchange rate of the Mexican peso to the American dollar is 9.52 to 1. If you went on vacation to Mexico and bought a jacket that cost 450 pesos, how much did it cost in dollars? Okay, so first thing I'm going to do is turn this ratio into a fraction. So 9.52 over 1. So the 9.52 is the peso, the 1 is the dollar. So for every 9.52 pesos, that comes out to $1. So the way that we're actually going to find how much the jacket cost in dollars is we're going to multiply this ratio times how much we spent. Now, we spent the money in pesos, so I'm going to have pesos in my numerator just like I have here. So times 450 pesos. And I'm going to put that over X because I don't know how many dollars that is. Next thing I want to do is do our cross product or cross multiply. And I would get 450 equals 9.52x. Next step, divide by 9.52 because I'm trying to get x by itself. And by doing that, it cancels out on this side. So I have x equals 47.2689. Now we're trying to make this into dollars. So if that is the case, whenever I have cents, I only go to a hundredths place. I don't keep going with my decimal. So the answer that I'm going to do is I'm going to be looking at 47.26. Now, the number next to the 6 is an 8. So it's 5 or higher. So that means I'm going to have to round up. So my answer would be actually 47.27. So $47.27 is how much that jacket cost in dollars. Okay, so we're on page 4. On this page, what we're doing is we're having problems that are supposed to have real world applications. So each of these word problems are stuff to use similarity in a real world sense. So for number 1, it says a building casts a shadow 180 meters long. At the same time, a pole 3 meters high casts a shadow 9 meters long. What is the height of the building? So by using similarity, we're actually going to be able to figure out what the height of that building is. Now, first thing, and it even says in the directions, is let's draw the picture first. Let's draw it. So let's see Coach Carr, the artiste. So first thing I'm going to do is draw a building. And I'm going to make it look fancy for y'all. Ooh, Now, we don't know the height of this building, but what we do know is that it's casting a shadow that is 180 meters long. Then we also have a pole that is 3 meters high. So I'm going to put a little pole here. And that pole is 3 meters high. And it has a shadow that goes out 9 meters long. So the ratio for the smaller one, this 3 meters high, 9 meters out for the shadow, could have this ratio of 3/9. Now, the bigger building, the one that we're trying to find the height for, we don't know the height. Now, the 3 came from the height of this small post. Now, since I don't know the height of the building, I'm going to put it as a variable, and I'm just going to make the variable x. Now, I do know the length of its shadow, though. The length is 180 meters. So now I have set up an equation where I can actually go ahead and start trying to solve this. What you want to do now is your cross product or cross multiplication. So 3 times 180 and 9 times x. Well, 9 times x is 9x, and 3 times 180 is 540. The next step here would be to divide both sides by 9 because I'm trying to get x by itself. So it cancels out over here. And now I would have x equals 60. So the height of this building is actually 60 meters. So make sure that you use the correct units. It even says it up here. Use the correct units. So since I know it's 60, I have to make sure I say 60 meters. Okay, so the next problem that I'm doing with you is number 4 on page 4. This one says that Felix wants to find the height of the tallest building in his city. He stands 339 feet away from the building. There is a tree 31 feet in front of him, which he knows is 21 feet tall. How tall is the building? Round to the nearest foot. Okay, first thing we should do is always we want to, if you have a word problem, draw it out. Now, a lot of it has been drawn for us, but there is a few things that we know. Like, first of all, Felix is standing right here. So there is Felix, my nice little stick figure. It said that he stands 339 feet away from the building. So the full length from where he stands to the building is 339 feet. They also tell us that there's a tree. So they have this little tree in here, and it's 31 feet in front of him. So from him to the tree is 31 feet. They also tell us that he knows that this tree is 21 feet tall. Don't ask me how he knows it, but he does know it. So with this information, I will actually be able to figure out the height of this building based on similarity. So first thing I'm going to do is make a ratio between the tree and how far he's standing from that tree. So the height of the tree is 21 feet. So I'm going to put that in my numerator. Then in my denominator, I'm going to put how far away he was from it. So 31. That should be proportional to the height of this building and the length to that building. So I did the height of the tree in the numerator. So the height of the building, which is what I'm trying to find, I'm going to have that in my numerator. And since I don't know what it is, I'm going to make it a variable. I'm just going to make it x. Now, I do know how far away he is from it, though, which is 339 feet. Now that I have set up an equation where I can actually solve for something, what I need to do now is our cross multiplication or cross product. So 31 times x is 31x. 21 times, what is that? 339 is equal to 7,119. So definitely knew that off the top of my head, didn't have it written down already. Next step is to divide each side by 31 so that I can get x by itself. Now you have x equals 7,119 divided by 31 is 229.645. Now, they tell us to round to the nearest foot. To round to the nearest foot, that means rounding to the nearest whole number. So I'm looking at the first decimal. It's a 6, so it's 5 or higher. So that means I'm going to have to round my whole number up. So it's going to come out to 230. And in this case, the units that we were working with the whole time was feet. So our answer would be 230 feet.